What's happening, dogs? Mr. Allen here with some semester 2 review on circles in geometry, specifically for my GeoCon geometry and construction class, but definitely applies to pretty much any geometry class here, so this is going to be dope. All right, circles. We want to fill in the chart below by describing how you find each of the angles related to the arcs. So for the central angle, it is equal to the arc measure, okay? The on angle is the arc divided by 2. All right, the out angle is your arc minus the arc divided by 2, okay? Now that would be your big arc minus your small arc divided by 2. And then our in angle, is equal to the arc plus the arc divided by 2. And I think it's kind of helpful to have like a general picture for most of these here, so I'm going to zoom in. For central angles, it's going to be whoop, central, boom, boom. That's my central angle right there. For my on angle, right, we're going to have a circle, and it's going to be on the circle. That's one of the possibilities. And another possibility would be something like this, where you'd have an angle where you have a chord and you have a tangent line. So it's going to be this angle right there. So those are the different types of on angles that you could possibly have. And then for out angles, we're going to have something that looks more like this guy right here. So we have, that's the usual one you'll see. But you could also have something that looks like this, where you have a secant line and a tangent line where it just touches right out there. And another, oh boy, I'm running out of room. Let's go right here. We could also have where it looks like an ice cream cone. 2 tangents, right? Those are all examples of out angles. And then for an in angle, you're just going to look like this. It's going to be 2 chords, crisscross, applesauce, not through the center there, okay? So there we go for all of our angles. All right, you need to know those formulas. I would definitely jot them down with a diagram on your formula sheet. It's kind of worthless without the diagram, so make sure you know which arcs we're working with, okay? If you need another explanation on that or further explanation, I have one of the videos in my playlist for the review as well, where it explains all of them in detail with examples, all right? So if the circumference of a circle is 22 pi centimeters, what is the area of the circle? Well, circumference formula is 2 pi r. If you don't have that, jot that down. So I know that 22 pi is equal to 2 pi r. I would cancel out my pi's and divide by 2 on both sides. Really, we're dividing by pi on both sides, all right? And I'm going to get r equals 11. Now I can use that r to get my area. So area of a circle is equal to pi r squared, pi times my radius squared. So that's going to be pi times 11 squared, which will be 121 pi, and we have ourselves centimeters, so centimeters squared. Beautiful. Done. We're going to skip over these. We did not cover them. All right, number 5 here. Find the area of the shaded region. Ah, that's exciting. Let's do it. So I have, wonderful, the lights are off, 4 meters for my side of this square, right? Because a square is going to be around that circle, right? So since a circle is nice and perfect and a square is nice and perfect, they work together so nicely, yes? So the area of the square is going to be equal to 4 times 4, which equals 16. Now the area of the circle portion, which is what we don't want, is going to have a radius of 2 meters. So we're going to have pi times 2 squared, which is 4 pi. So our shaded region is going to be the square, which is 16, minus the circle, which is 4 pi. Beautiful. That's awesome. And that would be meters squared. You can plug that into your calculator and get a decimal. And it's actually not a bad idea to plug that in there. Make sure you have them in the right order. If I do 16 minus, then we have 4 pi, second, then the caret, that gives me the pi. I would get 3.433. All right, so we have a positive number. That's kind of important, right? You want to have a positive number for area, not negative. No negatives for area. All right, here we want to find the circumference of the circle. Well, fun fact for those of you that don't know, but this is going to be a right triangle because it's inscribed in a semicircle. Dope. All right, so I can hit it with some Pythag to get this guy right here. It's a 6, 8, 10 triangle. That's my 3, 4, 5 triple times 2, right? All the sides get doubled. There we go. If not, you can hit it with some Pythag of 6 squared plus 8 squared equals c squared, or your diameter squared, I guess, in this case here, and solve using Pythag. All right. So now I have my diameter. Well, circumference is equal to pi times diameter, or 2 pi r, but either way, we're going to get 10 pi for this one right here. Dope. Inches. All right. Cruising through circles. This would be the most important part right here for your final. I'm going to try to turn the lights on. So we have ourselves a circle. We want the central angle, looks like there for x, right, for this first one here. Well, we know that the central angle is equal to the intercepted arc. So x here is going to be 62 degrees. Now for this next one, I have an in angle. We know that in angles are equal to the arc plus arc divided by 2. So I'm going to have 30 plus 100 divided by 2. That's equal to x. So that's 130 divided by 2 equals x. So x is going to equal 65 degrees. Boom. Circle that one right there. All right. Next one, I have an on angle. How do I know this is an on angle? Because my vertex is on the angle. Back to this one, this is an in angle because my vertex of the angle is in the circle. And here my vertex is at the center, right? That's how we know if it's an in, out, on, or central angle, okay? So this is an on angle here. So my formula would be my angle is equal to the arc, which is 70 divided by 2. So x equals 35 degrees. Beautiful. This one over here, part D. This right now is an on angle. It's that second one, this one right up here, this guy. It's that situation there where you have a chord and you have a tangent line that make up that angle, okay? So for that one, again, my intercepted arc is still 150 right there. So I'll do 150 divided by 2. That equals 75. So x is equal to 75 degrees. Boom. Now I got myself an out angle, okay? Out angle situation going on. But I have my two arcs, which is nice. So x is equal to my big arc, which is 120, minus my small arc, which is 36, divided by 2. So my numerator is going to be 84. Yeah, x equals 84 over 2. So x is going to equal 42 degrees. Nice. Excellent and fantastic. Okay, last one here. So we have this out angle, but it's with two tangents. There's a fun little formula for this one. This 140 and that x right there will add to 180. So x is going to equal 40 degrees. 180 minus 40. Or sorry, 140. Oh, there we go. All right. So 40 degrees for that last one there. That was exciting stuff. Very exciting stuff. All right, couple more here. Couple more, and then we're on some dope trig, yo. All right. If AB is equal to CD, so these two are equal, and AD equals 120, and BEC equals 75, find AB. All right, this is probably the most challenging one that we have here. So the first thing I'm going to do here is I'm going to solve for this arc BC right there. That was a terrible, terrible line. Let's see if that's a little better. All right, I want to solve for that. I'll call that X, right? That is an intercepted arc of that angle 75 degrees. So it's an in angle right here with the 75, all right? So I can use my in angle formula, which is the arc, x, plus the other arc, 120, divided by 2 is equal to that 75. I'm going to multiply by 2 on both sides. So we have ourselves x plus 120 equals, and I have 75 times 2 is 150. So if I subtract 120, I get 30 for that arc measure right there. All right, so this guy is 30. Now, back to the AB equaling CD. If those two chords are congruent, then my arcs are congruent. So that means that I'm going to do it in purple here. This arc here and this arc here have to be the same measure. Well, what's left over for them, right? So if I take the 120 that we currently have and the 30 that we have, add them together, that's 150. If I take 360 minus that 150, I get 210. So whatever's left over there is 210. Divide that by 2 because they have to be the same. I'm going to get 105. So 105 degrees. Now, if you didn't get that one fully, if you're like, bro, what? Don't worry about that one too much. Not quite as complicated there on your final exam, but definitely a nice stretch of reminding or seeing, what we could really do with that particular problem right there. Okay, so a lot we could do with arcs, but not quite that complex on your final exam. So have no fear. All righty. Next one, number 9, find the circumference in terms of pi of a circle with an area of 36 pi centimeters squared. So area, again, is equal to pi r squared. And I have 36 pi equals pi r squared. Well, I can divide by pi, and those guys are gone, right? So now I'm just left with 36 equals r squared. I can square root both sides. And I'm going to get r equals 6. Is that my answer? No. All right. Circumference is 2 pi times my radius. So that's going to be 2 pi times 6, which equals 12 pi centimeters. Ooh, that was dope, man. That's it for circles. We're going to cut it off here. I'll do trig in another video. I know you want to get trig with it. Deuces, dogs.